My name is Ramazan ERDEM. I am an associated professor doctor in textiles technologies of Akdeniz University. My presentation is related to technical textile yarns. As you know, textile products whose primary objective is to meet some technical requirements or functions are termed technical textiles. Consequently, traditional apparel and home textile products are outside the domain of technical textiles. The development of new fibers and new processing technology is widening the areas of application. Technical yarns can be classified on the basis of source, for example, raw material, or structure and form, of course. So, before just starting talking about the technical textiles, maybe we can just mention some information related to raw materials of textiles. We can just divide the yarns and raw materials into two main subcategories, like natural ones and artificial ones. We can say that natural products can be again divided into two groups, like low tenacity ones and high tenacity ones. In the group of low tenacity, we can give the examples of cotton, wool, silk, and jute fibers. With the high tenacity ones, we can give the information and example of flax, rami, and hemp fibers. And in artificial group, we can again say that we have high tenacity and very high tenacity ones. To give the examples for high tenacity, we can say that nylon, polyester, polyethylene, and polypropylene fibers. And high tenacity one, very high tenacity ones can be exampled as carbon, aramid, and glass fibers. And you know, we can use these fibers in the form of monofilaments and multifilaments. They can be flatly used as a tape, and they can be, you know, again, spun yarn, coarse spun yarn, and piled cable braided structures can be used as well. So, of course, in the monofilament yarn types, we can change the cross-sectional shapes of the fibers, like you see on the picture. And I need to state some properties of these different cross shapes of fiber types. For example, a non-circular cross-section encourages wicking. The surface area of the fiber increases the cross-sectional shape, becomes more and more non-circular. Monofilaments have high bending rigidity and more resistance to abrasive damage. So you can also see some structural production methods and the end products on this slide. So when you look at the picture carefully, you see monofilament type, multifilament type, commingled yarn, structure tape yarn, fibrillated tape yarn, spun yarn, and coarse spun yarn. Every structure has its own specific property, of course. So when you characterize the technical yarns, there are some parameters you need to focus on. For example, dimensional parameters such as linear density and diameters. The other one is structural parameters, and maybe the most important property in this group is twist and its direction. Constituent fiber parameters, number of filaments, for example, in cross-section, filament cross-sectional shape, length, linear density, crimp cross-sectional shape are some important details that we need to concentrate on. In the case of linear density and count, we should mention that linear density or yarn count, yarn number, and yarn size are indirect expressions of fineness of yarn. The fineness is not expressed by the yarn diameter, because firstly the diameter is not stable and uniform along the yarn length in the case of spun yarn. Secondly, the cross-sectional shape may not be the circular for both yarn and fiber. Hence, it is expressed by either measuring the weight of a known length of yarn or measuring the length of a known weight of yarn. There are two specific calculation and measurement or definition methods briefly. So you can see some specific values and information about specific yarns. Okay, twisting is very important, another characteristics when you just load the properties on the yarn. The twisting can be S twist and Z twist. Why we apply twisting on the yarns? To improve the coherence between the fibers, though not really to improve the strength in filament yarn, to improve both coherence and strength in stable yarn, fiber yarn, to improve abrasion resistance and fatigue, to enhance flexural rigidity, to make the yarn compact, to reduce snagging. These are the reasons that we applied twistings to fibers. So packing of fibers are important. You can see on the picture on right hand side at the bottom, there are two different examples of packing. We call the left one open packing, the other one is close packing. Since yarns are assemblies of fibers, it becomes important to know how the fibers are packed. Whenever a yarn encounters bending, twisting, or tensile deformation, fibers are subjected to forces that cause them to move relative to each other. The ease of movement of fibers within a yarn depends upon how the fibers are packed within the yarn. While in some products a low packing density may be desirable, in others a highly packed structure is beneficial. So the packing of fibers is objectively defined by the packing coefficient. There are some also specific yarn types, fiber types, and related mechanical properties of these yarns. So in the case of defining and determining these properties, we can choose and make a decision what kind of type yarn we will use for our end product of technical textile materials. Thermal behavior is another important characteristics. Fibers react to heat in different ways, as we know. They may shrink, change color, soften, become sticky, melt, decompose, or carbonize. Fibers such as cotton have no melting point and char at very high temperatures. Nylon and polyester have melting point as well as glass transition temperatures. So we can just modify the characteristics of these fibers by playing around these properties. Celluloid fibers, for example, burns easily and quickly leave some ash behind of it. Acrylic fibers cannot be ignited so easily, but once ignited, burn very fast. Polyester and polyamide are difficult to ignite. However, the fiber melts and drips during the process. And aramid and nomex, maybe we should state in this case, are highly heat resistant fibers and are therefore used for making yarns for firefighters' protective clothings. And thermal conductivity is another specific character, that warmness and coolness are associated with thermal conductivity of the fabric, which in turn is decided mainly by the bulk of the fibrous assembly, the thermal conductivity of the fibers, and the surface roughness of the fibers or yarns or fabrics. Polypropylene fiber has the lowest thermal conductivity, whereas cotton has the highest. You can see on the table some specific properties related to this thermal conductivity of different fibers and the yarns made of them. Resistance of fibers to various environments are also definitive. In that case, we can see a very comparative table on the slide. So we see that, you know, high molecular polyethylene polymer showed an excellent performance in terms of resistance to UV, abrasion resistance, acid resistance, and alkali resistances as well. So we just talk about the monofilament and multifilament yarn types, and so I'm just going to move quickly on these slides. And you can see some yarns used according to application or special properties on the slides. And generally we can say that these technical yarns, of course, can be used in technical applications such as protective textiles, transport textiles, geotextiles, construction-based textiles, technical apparel, farming, medical and hygiene textiles, etc. These are some, you know, on the second column, these are some examples of the specific products related to these areas. And on the right hand side, you can see some used polymer and fiber types as well. And we can just produce these fibers as a monofilament form structure or multifilament ones. On this slide, you can see some specific examples and yarn counts related to, you know, tires, safety belts, cut-resistant fabrics, sailcloth, airbags, seatbelt webbing, etc. So, if you talk about the technical textile yarn market, we can say that it is a growing market. Advancement in material and processing technology causing replacement of solid materials used in building and composites. Some stringent environment, filtration and safety regulations, for example, in protective clothing area, also requires some specific properties from these kind of products. Growth in income in developing countries leading to more recreational activities such as some sports areas. Aging population, you know, these are all demands from the technical yarns market. So technical yarns are dominated by polyester and polyamide, which together have captured almost 85% of the market. The most prosperous markets are in China, Taiwan, and Brazil. Annual global production has been estimated to be 2.6 million tons. The major consumer of industrial yarn is the automotive industry, according to the literature. The demand for Indutech, I mean industrial technical textiles, filters, for example, conveyor belts, will increase mainly in China and India. The demand for Build-Tech textiles is directly dependent on construction activity and major international events such as the Olympic Games, World Cup, Asian Games, Commonwealth Games, etc. The growth of geotextiles used in building roads, railways, bridges, dams, etc. will be in the order of almost 5.6%. So these are my introductory presentations related to the end products and also production types. Since I have a very limited time in presenting my presentation, I have to finalize my presentation over here, and I would like to thank for your attention.